Hi dear children, this is teacher Geeta. Grade 10 physics. The topic is thin lenses. You know that lens, there are two main types of lens, convex lens and concave lens. What is the use of lens? The lens undergo refraction or lens bend light and form images. Well, there are two main type of lenses, and here the diagram showing the two types of convex lenses and concave lenses. Convex lens, this curve outwards and are fatter in the middle, but concave lenses, these curve inwards and thinner in the middle. Now we have to discuss about the difference between converging and diverging lenses. The convex lens, that is converging lens. These are thickest in the middle and thin around the edges. When rays parallel to the principal axis passes through the convex lens, they are bent inwards. The point F where they converge or meet is called the principal focus, and its distance from the center of the lens is the focal length. The next slide I explain more about that one. Now this is about converging lens. A ray can pass through the lens in either direction, so there is another principal focus on the opposite side of the lens and the same distance from it. Here, what is the difference between converging and diverging lenses? When light is refracted as it passes through the glasses, that is lens is made of glass, it is bent. And converging means the light intersect or converges on back side thicker in the middle, that is converging lens. And diverging means the light spread out, that is concave lenses. They are thin in the middle and thickest around the edge. When rays parallel to the principal axis passes through the concave lens, they are bent outwards. And the principal focus is the point from where the ray appear to diverge. But here converging lens, F is the principal focus. Here diverging lens, here it is the principal focus. Here it is the converging lens, thicker across the middle, thinner at the edges. And here it is thinner across the middle and thicker at the edges. That is the difference between converging and diverging lenses. Now this definition you should remember. The principal axis is a convection line that is perpendicular to and passes through the center of the lens, the principal axis. And the principal focus, this black line is called the principal axis, the middle line. And what is principal focus? F is the point through which all rays traveling parallel to the principal axis before refraction passes through or appear to come from after refraction. And this is the focal point or the principal focus. We see what is principal focus. All the lines, the converging lens, all the rays are bent inwards, and the point F where the converge, all the rays converge or meet is called the focal point or principal focus. And in diverging lens, it is the point where it is diverge or spread out, that is the focal point of diverging lens. And the distance between, what is focal length? The distance from the center of the lens, the center of the lens, from the center of the lens to the principal focus, this distance is called focal length. I think we understand that principal axis, principal focus and focal length. Now we have to describe how to draw a ray diagram. Here it is showing to draw ray diagram. First one is a ray from the object to the optical center. This is called the optical center. Here it is marked optical center. The ray from object through optical center. The second ray is the ray from object parallel to the principal axis. This one here it is. Parallel to the principal axis, then to the principal focus F. And the third ray, a ray from the object through F before we said that the other side also there is principal focus F, and to the lens, from F through F to the lens, and then parallel to principal axis. But these are the three rays. This way it is drawing a ray diagram and the formation of image also. Next we have to discuss the image by a convex lens. We have to place the object in particular position. In this picture, the object is in between F and 2F. See that ray diagram showing the formation of the image when the object is a distance between F and 2F. That is the focal point and the F and 2F from the converging convex lens. And where is the image formed? The image is beyond a distance from 2F or from the lens. It is real, inverted and larger size than the object. This is the object and this one is the image. From here you can see that this is larger than the object. But what are the characteristics of the image formed when the object is placed in between F and 2F? It is inverted, magnified and real image, and this is used in the projector. This type of lenses we are used in the projector. Next is the image beyond 2F. The object is placed beyond 2F. So where is the image formed? The image is formed in between F and 2F here. So characteristics of the image is inverted, diminished. This type of lenses we are used in camera. But here it is inverted image, it is diminished. And next one is the object is placed in 2F. But where is the image formed? The other side same, in 2F itself the image is formed. Here it is, the image is real, inverted and same size as the object. But these are the three examples of the characteristics of image formation. Now once again I am telling that characteristics of the image formed by a convex lens. Distant object, if that is beyond 2F, distant object that is beyond 2F. So real, real, but here it is real, inverted and smaller than the object, and it is formed at the F. The image is formed at F. Here object is beyond 2F. The next one, the object is at 2F and it is real, inverted, same size of the object, and it is image is formed at 2F itself. The next one is object between 2F and F, and here it is see that it is the image formed beyond 2F and real, inverted and larger than the object. And object is at F, no image is formed. The refracted rays are parallel. If the object is placed on the focal point here, no image is formed. The object between F and the lens, and the object is in F and the lens, but it is a virtual, upright, larger than the object, behind the object on the same side of the lens. These are some characteristics of the image formed by the object placed in different places. Now the ray diagram of a concave lens or the diverging lens. The ray diagram here it is see, when a concave lens, the image will always be diminished and right up, and it is upright and the virtual image it is. And this is about the ray diagram and showing the image formation of image. This is also showing like that ray diagram of diverging lens. But here it is, this is the focal point. Here they place the object is here, and then the image is formed between the focal point and the lens. It's a diminished image and virtual image. Next is the natures of the image using. Now we said there are magnified image, diminished image, inverted, upright, real. What are the meaning of this one? So now understand that magnified means bigger than the object. Diminished means smaller than the object. Inverted, upside down. And upright, the same way up as the object. Real means you can project the object onto a screen. Virtual means you cannot project object on the screen. Now, these are the meaning of the words we are used in image formation. Now, the image by concave lens. The image formed by a concave lens, the characteristics of image are virtual. It cannot be seen projected in a screen, and it is upright, smaller than the object, between the object and the lens it is forming. But this picture showing the formation of image using a concave lens. But here if you look at an object through the concave lens, it looks smaller and closer. If you move the object further out, the image will not move as much. This is about image formation of concave lens. I think you understand about thin lenses. Watch the video clearly and do the worksheets also. Okay.